I'm recording this for the earlier class, or for the basketball players that are gone. Okay? We're going to take the information on the left, and then try to go through some sample problems. When you look at the very beginning of page 13, it says this statement that you see right here. It talks about Ben's statement on page 13. It says Ben said for every $60, the 6th graders plan to raise, the 7th graders plan to raise 90. And then it says he looks over at the principal's thermometers and he agrees because he looks at the principal's thermometer and what does he see that matches up with that statement? Yeah, what does he see, Juan?
Oh, that there's one of the goals is 300 and the other goal.
But even more, just about the 60 and the 90. What does he see when he looks at the thermometers for 7th and 6th graders? When you look at the 60 for the 6th graders and the 90 for the 7th graders, what does he see?
That once the 6th graders get like $60, the 7th graders get 90.
Yeah, he sees that they're lined up, right? And so from just the picture, he knows they're right. Does that make sense? And then he goes on and says, so Ben also claims for every $30 the 6th graders plan to raise, the 7th graders plan to raise 45. So what do you think, Jay? Do you see where he's getting those claims?
Yeah.
And it's because they line up, right? So the picture's a great tool, but it's a lot of work. Because to do that tool, you need everything. Go ahead.
How do you always get 10 boxes, or can you change the number of boxes?
You could change the number of boxes. This is just what the principal did for her visual display. Isa?
I still don't get, I don't get why you do those little, dome-shaped things. Is that fun for fun?
You mean my little jumps?
Yeah.
I was just making sure people understood how to count up.
Oh.
So this is 30, 60, 90 on that thermometer. But on this thermometer, it would represent 45, 90. Each jump is 45 on the 2nd thermometer. And on the 3rd thermometer, each jump is how much, Isa?
15.
15. So I was just showing people how to count up.
And you also do it with the,
Yeah, okay. So 2 different questions, and then Solon will take your question. I think we could all agree, that the principal's visual is nice. I'm going to wait till everybody's ready to listen. But it's also a whole bunch of writing. And the ratio table can do the same thing quicker. So it asks you to decide if you agree with the claim. So we agree with the claim, but I'm going to show you that you could use the ratio table to show the claims correct without doing all of that writing. So Briley, can I divide both of these by a common factor?
Yes.
What? What's the easiest one? You'd say 15?
50.
50? Oh, okay. I was going to say 10, but I'm going to go with 50. So I like that. So if I divide by 50, how many times does it go into 300?
It goes into 300.
6 times. So he made a big quick jump, and it goes into 450
9 times.
9 times. Okay? Now, if I want to check Ben's claim, I could build my ratio table up. I don't always have to reduce it down. So Anderson, if I want to check Ben's first claim, what do I have to multiply this by? To get to Ben's first claim.
10.
Right, I multiply by 10 because Ben says that for every $60 the 6th graders make, the 7th graders make 90, and 9 times 10 is 90. So I've agreed with Ben's claim without doing tons of work. Tim. Pardon me?
Look on the board.
Yeah, it's up there.
So the other claim that Ben has was that for every $30 the sixth graders made, the seventh graders made 45. So Salon, how can I get the sixth graders down to $30?
Divide it by 2.
Right. And so this is a 30 and that's a 45. So by using this ratio table, I've shown enough work to show that I agree with Ben's claim. And then I would just write a little sentence, or we can write a sentence, we agree with Ben and showed our work above in the ratio table, okay? So I like the ratio table because it can shorten things up. The second thing you have to be able to do is write it for every statement. So we're going to use the ratio table. So start one out for me, Avi. For every what? Use that table and make it for every statement.
The one off the book?
Yeah.
Okay. For every $30 the sixth graders make, the seventh graders make 45.
For every $30 the sixth graders make, the seventh graders make 45. So for every $30 the sixth graders make, the seventh graders make 45. Do you guys agree with that?
Mm-hmm.
So write that down and then write one of your own in, and we'll compare. Okay, we're writing a ratio statement now. If they ask you to write a ratio statement, you would actually use the word. And like Ideen just said up here, the ratio of the sixth grade goal to what? What was it? Yeah, to who? Sixth grade goal to?
Sixth grade.
To the seventh grade goal. Is 2 to 3. So that's just an example of a ratio statement. And you can even make a fraction statement. What would the fraction statement be? Somebody I haven't heard from yet. I don't think I've heard from you today, Lydia. The fraction of the sixth, how would you make a fraction statement? The sixth grader's goal is what fraction of the seventh grader's goal? How would you say that? That's right. So up here, you could say the sixth grader's goal is 2/3 of the seventh grader's goal. Does that make sense?
Yeah.
And those are the things you're going to be using tonight. So a fraction statement also. They don't ask that, but it's a good thing to know. A fraction statement. So that would be the sixth grader's goal is 2/3 of the seventh grader's goal.
It's going to be on our homework, right?
A little bit of everything, yeah. What it doesn't say on your homework is to use a ratio table, but I think it helps you make your work easier.
Wait, what does this little like dot between the 2 and 3 mean?